For our first training mission, we will use the front and rear cockpit interior check procedures of the real aircraft as a way to familiarize ourselves with the F-15E. In order to not disrupt this mission's logic, this instructor will control the change of seats as needed by the instruction flow. Please, do not try to change seats on your own. We will begin with the pilot's front cockpit, reviewing the different elements on a left-to-right sweep, following the front cockpit interior check procedure. Press spacebar to begin. Front cockpit. Left console. Ground power panel, all switches as desired. While usually the F-15E is started without relying on ground power, it is possible to connect an external ground power unit and enable its use with the external power switch of the engine panel on the right console. Once enabled, the switches of this ground power panel controls which group of systems or instruments will receive electric power. The switch 1 controls power to the hydraulic pressure gauges, fuel flow, engine monitor, fuel quantity indicator, flaps, speed brakes and the automatic flight control system, AFCS. In position B, all systems are energized. In position A, all systems except the AFCS are energized. The switch 2 enables power to the AHRS, Standby Attitude Indicator, MAD and EGI, if equipped. The switch 3 controls power to the ADC, Air Data Computer, EAIC, Enhanced Air Inlet Controller, AOA, Angle of Attack Sensor, VVI, Vertical Velocity Indicator, IBS, Interference Blanker Set, and VTRS, Videotape Recorder System. The switch 4 gives power to the ILSR, ILS Receiver, TACAN, RMR, Remote Map Reader, not fitted to RF-15E, and DMS, Digital Map System. The PAX switch provides power to the Programmable Armament Control Set. In its off position, PAX is de-energized regardless of power source. The MPDP/AIU1 switch enables power to the Multipurpose Display Processor, MPDP, and the Avionics Interface Unit No. 1, AIU1. In off position, they are de-energized regardless of power source. This is a ground maintenance diagnostic panel, not simulated, as it is not used by the pilot. Armament Safety Switch, Master Arm, confirm it's at safe. The Master Arm switch has two positions. When safe is selected, no weapons can be employed. In Arm, Up, position, power is applied to the Master Arm switch, which in turn provides power for weapons release, launch, and gun firing. Although this breaks our left-to-right sweep, it is a critical safety step to ensure that any aircraft weapon can't be fired accidentally while on the ground. Flick the switch to return to our sweep. Emergency air refueling switch cover, confirm it's down. If the air refueling slipway door can't be opened normally, then it can be opened with a pyrotechnic device by placing this emergency air refueling switch to its open position. The door will not be able to be closed after using this switch. Normal slipway lighting will be available, but the ready light will not go out during refueling, nor will the boom lock in the receptacle. External fuel tank pressurization can be restored by placing the slipway door switch to its close position. Flick the switch cover to continue the familiarization. Integrated communications controls, as desired. This panel contains controls for the IFF transponder set, VHF, UHF, and intercom controls, as well as volume knobs for different systems. IFF panel. The Interrogation Friend or Foe system, IFF, is not fully modeled in DCS, and the options for different encrypted communication modes are not functional in the current version of the module, even though their switches are implemented. In real life, IFF is a communications device that allows an aircraft to transmit an interrogation message, which other aircrafts can reply with a special code. If the reply code is correct, the other aircraft is presumed friendly. If the reply code is wrong or there is no reply at all, the other aircraft can be presumed foe. Over the years, the IFF interrogation schemes have evolved, resulting on diverse interrogation and reply modes. The F-15E can use modes 1, 2, 3A, Mode 4 and Mode C. Mode 4 is the most secure because of its encrypted transmissions, so it is the preferred mode to employ. This is the IFF Mode 4 reply selector. The A position enables Mode 4A reply. B selects Mode 4B reply. Out disables all Mode 4 replies. Flick the switch to continue. This is the Mode 4 reply switch. In its light position, when the Mode 4 system replies to a valid interrogation, causes the adjacent reply light to illuminate. In audio rec allows both an audio tone and the reply light to illuminate. Off turns the system off. This is the IFF master switch. In low, the system operates in reduced sensitivity. In norm, full system sensitivity is enabled. Emergency enables response to interrogations in modes 1, 2, 3A, C and 4. Radio panel. These switches are the UHF and VHF antenna selectors to choose whether to use either the upper or lower antenna. On real life you would use upper when flying low over the terrain, and lower when flying high, but on DCS their effect is not simulated. Flick either switch to continue. The tone selector switch allows the crew to transmit tones on the UHF-1 or UHF-2 radio by selecting either position. This is the cipher text selector switch. In its only position, the radio can only receive ciphered text and not clear text communications. In norm, both types are allowed. On DCS, ciphered communications are not simulated. Mics panel. The Mode 4 crypto switch chooses between hold, stores the IFF codes in memory, normal operation, zeroing the codes at power shutdown, and zeroing the codes immediately. Its effect is not simulated. Mic is the intercom function selector switch. Selecting radio override will attenuate the radio communications in favor of intercom communication. However, the voice warning messages are not overridden. Selecting on provides direct communication from the cockpit in which it is selected with the other cockpit and/or the ground crew. Selecting off turns off the microphone for intercom purposes. However, the crew member can still transmit on the radio. For normal operation, set the switch to on. Voice warning silence push button. Pressing this button silences the voice warnings and the oral tones in progress for 1 minute. If still present after 1 minute, the warnings will be heard again. Volume panel. These are the tactical electronic warfare system volume knobs. The top knob is used to set the volume of caution sounds, the bottom knob controls the missile launch warning volume. These knobs controls the audio volume of the intercom system, top 1, and the weapon's lock-on tone, bottom 1. These knobs adjust the volume of the ILS audio, top 1, and TACAN beacon sounds, bottom 1. EWWS, Electronic Warfare Warning Set, Enable Switch. Set to off, guard down. EWWS is part of the jet's defensive suite. The functions of the switch are not yet simulated. Flick the cover to continue. IFF antenna switch, set to both. This switch selects which antenna the IFF will use. Upper, lower, or both, provides automatic antenna selection. Flick the switch to continue. Sensor control panel. Confirm all switches are off. This panel contains switches for different onboard sensors and systems, such as radar, navigation FLIR, and INS. In anticipation of the aircraft start, all this equipment should be powered off to reduce electric power demand while the engines are starting. This is the master control knob for the Joint Tactical Information Distribution System. TIDS is a secure and jam-resistant data communication system, which enables the exchange of real-time tactical information between friendly forces, concerning both friendly and enemy forces. The information exchange includes command and control data and force identification and location data. The TIDS is not available in the current version of the F-15E module. Flick the knob to continue, but leave it at off. Central Computer Reset button. The F-15E Central Computer, CC, performs mission-oriented computation from data received from control panels and subsystems aboard the aircraft. The computations include air-to-air and air-to-ground steering, weapon delivery, navigation, flight director, control and display management. This button, if pressed, resets the central computer. To be used only in case of suspected problem with the computer. Press the button to continue. The INS mode knob controls main functions of the inertial navigation system of the F-15E. An inertial navigation system, INS, is an electronic system that uses a variety of environmental sensors that are able to detect and measure the change in motion of an object. Using sensor data, an inertial navigation system can determine the position of the vehicle or object relative to its starting point. We will study the INS fitted to the F-15E more in depth on a dedicated future navigation training mission. Flick the knob to continue, but leave it at off. The NAV-FLIR system provides infrared, forward terrain video on the HUD display in support of the terrain-following radar operation, which is not yet available in early access. The AAQ-13 navigation pod has to be installed on the jet in order for the pilot to be able to use the navigation with forward-looking infrared vision (NAV-FLIR) capabilities. The NAV-FLIR gain, smaller top knob, and level, larger bottom knob, control the pod settings itself, and can be used to adjust the image displayed on HUD repeater on the MPD or MPCD, independently from the controls for the HUD. This is the navigation FLIR power switch. Can be set to off, standby, and on. Flick the switch to continue, but leave it at off. Terrain following radar power switch. Can be set to off, standby, or on. The TFR works by scanning a radar beam vertically in front of the aircraft and comparing the range and angle of the radar reflections to a precomputed ideal maneuvering curve. By comparing the distance between the terrain and the ideal curve, the system calculates a maneuver that will make the aircraft clear the terrain by a preselected distance, often on the order of 300 feet. Using TFR allows the F-15E to automatically follow terrain at very low levels and high speeds. The terrain following functions are not yet available in the early access stage of the simulator. The radar altimeter indicates clearance over land and sea, from 0 to 50,000 feet. Radar altitude is utilized by the AFCS, Lantern Navigation Pod, the Terrain Following System, TF, and the Low Altitude Warning, LAW. Radar altimeter switch can be set to off, which also disables LAW warnings, on, and override, which deactivates the radar altimeter, but leaves the LAW and TF warnings on. Flick the switch to continue, but leave it at off. The F-15E employs the APG-70 radar, which gives the pilot advanced capabilities both for air-to-ground and air-to-air combat. The radar power knob on the sensor control panel has the following functions. Off, no power is coming to the radar. It is completely de-energized. Standby, standby mode. In this mode bit checks can be performed, not implemented yet, and the radar is warming up, which takes around 3 minutes. After that time, it can be placed in full operation. On, the radar is in full operation unless the aircraft is on the ground. If the knob is moved directly to the on position, the 3-minute warm-up occurs just as in the standby position. Emergency mode, it bypasses all the protective interlocks, except the wheel's on-ground detection, and places the radar in full operating mode. It still requires a 3-minute warm-up. E is displayed on the HUD. In the real aircraft, it is forbidden to use the radar in emergency mode during peacetime training missions. Fly-up enable switch. Armed, guard down. This switch is part of the terrain following system and in most situations should be kept in on position, guarded. The red cover can be down with the switch on either position, so make sure the switch is in the proper one. The TF system is not implemented yet for the early access release. Flick the cover to continue. Seat adjust switch. This switch has NCTR enable switch, as required. Non-cooperative target recognition is a feature that lets the radar scan for the signature of the turbine blades on the engines of an unknown target. This is a 1 or a 2-part process, which compares the database for both the type of aircraft and the presumed friendly or hostile nature of said aircraft. When in on position, it enables the automatic NCTR, non-cooperative target recognition, entry. Otherwise, only a manual recognition entry is possible. Flap switch, set at its up position. On the F-15E, each wing has a 2-position trailing edge flap. The flaps are electrically controlled, but hydraulically operated. This switch controls the position of the flaps. It only has 2 positions, up or down. When the flaps are down, they are protected from structural damage by a blow-up airspeed switch, which is set to automatically retract the flaps at 250 knots maximum. The flaps will automatically return to the down position at no less than 230 knots, provided that the flap control switch is still in the down position. Throttles, levers fully back, on the off position. Use the right Alt plus End key bind, for the left engine, right Shift plus End, for the right. Movement of the throttle is transmitted by mechanical linkage to the engine's main fuel control. A friction adjusting lever is mounted adjacent to the front cockpit right throttle, but its action is not currently simulated. Finger lifts on the front cockpit throttles couple the jet fuel starter, JFS, to the engine during starting. They must also be lifted to move the throttles below idle, and must then be released to move the throttles to off. Advancing the throttle from off to idle, during engine start, opens the main fuel shutoff valve in the fuel control, and turns on engine ignition. Movement of the throttles from idle to off, closes the main fuel shutoff valve in the fuel control, stopping fuel flow to the engine. Afterburner light off is initiated by advancing the throttle forward of the afterburner detent. You can customize the axis point at which your physical HOTAs will simulate the afterburner detent to be, which is useful for those HOTAs that have an actual AB physical detent. Move the throttle forward and back to 0, to continue the training. Fuel control panel. Set. On the F-15E, fuel is carried internally in 4 interconnected fuselage tanks, and 2 internal wing tanks. External fuel can be carried in 3 external tanks and 2 conformal fuel tanks. The external tanks can be mounted on the centerline and inboard wing station pylons and are completely interchangeable. Conformal fuel tanks are mounted on the outboard side of each engine nacelle. All tanks may be refueled on the ground through a single pressure refueling point. Airborne they can be refueled through the aerial refueling receptacle. The internal wing tanks and Tank 1 are transfer tanks. Tank 1 consists of 1 main tank and a right auxiliary tank. The tanks are so arranged that all internal fuel will transfer even if the transfer pumps fail. Conformal tanks' fuel is transferred by transfer pumps to any internal tank that will accept it. Engine bleed air pressure transfers fuel from the external tanks to any internal tank that will accept it, and also provides a positive pressure on all internal fuel tanks. Each CFT is pressurized by a self-contained ram air pressurization and vent system. Float-type valves control fuel level during refueling or fuel transfer operations. All internal, CFT and external fuel, except engine feed tanks, may be dumped overboard from an outlet at the trailing edge of the right wing tip. All internal fuel tanks are vented through the vent outlets at each wing trailing edge. The external tanks are vented through the vent outlets in their individual pylons. Each CFT is vented through an outlet near the back of the CFT. The fuel quantity indicating system provides fuel quantity, in pounds, of all internal, CFT and external fuel. Fuel dump switch. Norm. All fuel, except engine feed tank fuel, may be dumped by placing this dump switch to dump. With the landing gear handle down, external fuel cannot be dumped. When dump is selected, a dump valve in the right internal wing tank opens. With the dump valve open, the transfer pumps in Tank 1 and each internal wing tank will force fuel out the right wing dump mast. Conformal fuel tanks and/or external fuel tanks transfer into Tank 1 and the wing tanks, and is then dumped. Dumping will continue until norm is selected on the dump switch, or the bingo caution comes on, at which time the dump switch automatically returns to norm, terminating the fuel dumping. Dump will also terminate if only feed tank fuel remains. Flick the switch to continue. At cold start, set these switches as follows. Wing and center switches, norm. Conformal tank switch, stop trans. The reason why the CNF tanks are set that way is because, in flight, all external tanks are pressurized and can transfer fuel. On the ground, since external wing and centerline tanks are depressurized, no fuel will transfer from those tanks. However, the CFTs can transfer fuel on the ground since the CFT transfer pumps operate continuously. For this reason, this switch is set to stop transfer while on the ground, and then set to norm once on the air. Set the switches as instructed above, to continue the training. Slipway switch. Close. This switch is part of the air refueling system, as it operates the hydraulically operated slipway door. It has 3 positions. Close, closes the slipway door, turns on Tank 1 and CFT transfer pumps, and re-establishes external fuel tank pressurization and fuel sequencing. Open. Shuts off Tank 1 transfer pump, CFT transfer pumps, if operating, opens the slipway door and, providing the slipway door has opened, A. Depressurizes the external fuel tanks, if fuel low, light not on. B. Turns on the receptacle lights. And C. Turns on the ready light indicating the system is ready for boom engagement. Override. Accomplishes the same function as in open, plus the following. A. Allows boom locking, but the tanker disengage feature, both automatic and manual, is lost. B. The receiver must initiate all disconnects. And C. Bypasses tank 1 float switch and external tanks may be refueled regardless of fuel quantity in tank 1. Flick the switch to continue the training. External transfer switch. As desired. This switch defines the auto-transfer priority sequence of what is considered external fuel. In wing/center, the drop tanks are primary, and conformal fuel tanks back that up. For conformal fuel tanks, the opposite occurs. The backup is related to tank 1 fuel levels. The external transfer switch should be set to match the current fuel configuration of the aircraft. If you have wing end, or centerline external tanks installed, set the switch to wing center. If those tanks are empty, or you do not have them installed, set the switch to conformal tanks. The fuel will still feed if the switch is positioned incorrectly, for example, if the switch is set to wing center with no external tanks installed. However, there may be a cyclic fuel transfer process that depletes your internal fuel by around 1,000 pounds or so, before it kicks the conformal tanks to feeding. For DCS, the switch function is not implemented yet, so it always goes to drop tanks first, and then to CFTs. Conformal fuel tanks emergency transfer switch. As required. This switch should be in norm, with, or without conformal tanks installed. When operating on the emergency generator only, selecting either left or right, will deactivate all aircraft pitot heaters, and activate the selected, left or right, CFT transfer pump. Nuclear consent switch. Safe, cover fully closed. This guarded switch allows the pilot to release or jettison nuclear weapons on board. The functions of this switch are not implemented. CAS switches, on. Superimposed on the hydromechanical flight control system, is a 3-channel, 3-axis, control augmentation system, CAS. The CAS responds to electrical signals generated by forces applied to the control stick and to the rudder. These signals modify the control surface deflections commanded by the hydromechanical flight control system, to provide improved flying qualities. The CAS affects stabilator and rudder position only, the ailerons are not controlled by the CAS. For the autopilot to work, it is necessary that all 3 CAS switches are set to on. TF couple switch, off. This switch couples the terrain following system to the autopilot. Selecting off deactivates automatic terrain following. TF is not yet available in early access. Flick the switch to continue. Miscellaneous control panel, set. Anti-skid switch, norm. An anti-skid system is incorporated in the normal brake system, to provide maximum deceleration with controlled wheel skid. Anti-skid protection is not available on the emergency brake system. It also includes a pulsar system, where applied brake pressure is repeatedly interrupted to the wheel brakes. This provides a pulsating braking action which reduces the probability of tire blowout from locked wheels. The switch has 3 positions, norm, anti-skid is on when the gear is down, the pulsar is enabled, pulsar, turns off normal anti-skid protection but activates the brake pulsar, and off, turns off both the anti-skid and the brake pulsar systems. Inlet ramp switches. Set to auto. On this position, the Air Inlet Controller, AIC, automatically controls the air inlet system. The AIC uses angle of attack, aircraft Mach number and other air data system outputs, to automatically schedule the ramps and bypass door of the engine inlets throughout the aircraft envelope. The first ramp is locked in the up position until the engine is started. Set both switches to continue. Roll ratio switch, auto. The F-15E primary flight control surfaces consist of conventional ailerons, twin rudders, and stabilators, which are capable of symmetrical or differential movement. Lateral stick motion positions the ailerons, rudders, and stabilators to provide roll control. The ratio of aileron plus differential stabilator deflection to lateral stick motion, roll ratio, is adjusted automatically for different airspeeds, longitudinal stick position, and gear position. At subsonic speeds, the roll ratio is high. At supersonic speeds, the roll ratio is reduced. Additional roll ratio reductions also occur as the stick is moved forward or aft. If this switch is set to emergency, or if hydraulic pressures are lost, the roll ratio drives to a mid-range setting and locks there. In auto mode, it provides normal roll ratio adjustments. Landing and taxi light switch, off, mid-position. The landing and taxi lights are both on the nose gear strut. When the landing gear handle is up, then the lights are off regardless of this switch position. When the landing gear handle is down, the landing position turns on the landing light, the taxi position turns on the taxi light, and the off position turns all lights off. Canopy jettison handle, confirm it's forward. For canopy jettison, a pyrotechnic canopy remover operates independently of the normal canopy system. The canopy remover, behind the front seat, is designed to safely jettison the canopy only from the closed and locked position. Depressing an unlock button on the inboard side of the handle, and pulling the handle aft fires the canopy jettison system. Do not try to operate this handle, as it works even with no electric power. Press spacebar to continue. Instruments panel. Emergency landing gear handle. Check it's pushed in. Emergency gear extension is accomplished by pulling fully, either the front or rear cockpit emergency landing gear handle, and ensuring the handle is locked in the extend position. This bypasses normal hydraulic and electrical controls and hydraulically releases the doors and landing gear. The landing gear then free falls to the down and locked position. The landing gear doors will remain open. On DCS, a right click will turn the handle, while a left click will push or pull it. The handle can be pushed forward only when it's rotated from the vertical. Pull-push on the handle to continue, leaving it in vertical position. Arresting hook switch, check it's up. A retractable arresting hook is in the underside of the aft fuselage. It is electrically controlled, extended by gravity and a hydraulic dashpot, and retracted by utility hydraulic pressure. It takes a maximum of 2 seconds for the hook to extend and 10 seconds to retract. Flick the switch to continue. Landing gear handle, confirm it's down. The F-15E landing gear is electrically controlled and hydraulically operated. While weight is on the wheels, the gear cannot be retracted. When the main and nose gear are extended, the forward doors will be closed. Placing this handle in down position extends the landing gear. Moving it to up retracts it. The handle has a red warning light, which lights up if any landing gear is not locked in the commanded position. Flick the handle to continue, but leave it at its down position. Landing gear position lights, just above the handle, are marked nose, left, and right. Each of these green lights illuminates when its respective gear strut is down and locked. The warning tone silence button can be used to turn off the landing gear warning, which goes off whenever the following conditions exist simultaneously. Aircraft altitude is below 10,000 feet above sea level, airspeed is below 200 knots, rate of descent is greater than 250 feet per minute, and the gear handle is not down. Press the button to continue. The flap position indicator shows the status of the flaps. If the lights are off, that means the flaps are fully retracted. A yellow light indicates that the flaps are in transit. A green light indicates that the flaps are down. Pitch ratio switch, set to auto. On the F-15E, longitudinal flight stick motion positions the stabilators symmetrically to provide pitch control. The ratio of symmetrical stabilator motion to longitudinal stick motion, pitch ratio, is automatically adjusted for altitude and speed. This provides the same pitch response, constant G, for a given stick deflection regardless of airspeed. This switch has two positions. Auto, which provides normal system functions, and emergency, which removes hydraulic pressure from the hydromechanical pitch control system, and causes the pitch ratio and the pitch trim compensator to drive to a mid-range position, and lock. The pitch ratio indicator, positioned just above the switch, shows the ratio of the motion of the stabilator compared to the up and down stick motion. This ratio should be 1.0 at slow speeds and close to 0 at Mach 0.9, at sea level. Flick the switch to continue, but leave it at its auto position. Jettison select knob, check it's off, red button not pressed. When pressed, the red Jet button jettison stores according to the setup that the crew makes on the combat jettison page of the air-to-ground packs screen on any MFD. The jettison program to be used is selected with the highlighted knob. A right click turns it clockwise, while a left click turns it counterclockwise. Turn to combat with a right click. Combat, first press of the red button initiates combat jettison program 1, a second press initiates program 2. AA selects air-to-air selective jettison. AG selects air-to-ground selective jettison. Regardless of master arm switch position, when the jettison red button, in combat, AA, or AG positions only, is pressed and held for at least 1 second, all arming solenoids are automatically de-energized before jettison and all stores are jettisoned unarmed. To the left from the off position, there is an alternate release mechanism, which technically is not part of the jettison system, as they allow to drop live ordnance. Turn to alternate release, with a left click. Alternate release is a backup nuclear release mode, not simulated on DCS. Manual retard selects the manual weapon release mode and tail fuse only. Each release pulse releases one weapon from each selected aircraft station while the weapon release button is pressed. FF, free fall, selects an armed manual ripple release mode, with nose fuse only. Pressing and holding the weapon release button releases weapons continuously from each selected station until all weapons are gone or the button is released. Press spacebar to continue, leave knob at off. Fire lights, not pressed. The fire warning and extinguisher system provides engine and AMAD fire warning, emergency engine and jet fuel starter shutdown, and selective fire extinguishing. The extinguisher is a gaseous system which provides one-shot, one-compartment extinguishing capability. Electrical power is required to operate the fire warning and extinguisher system. During JFS operation, before the emergency generator comes online, only the AMAD system is operative. The fire lights on the fire warning/extinguishing panel in the front cockpit are combination warning lights and fire extinguisher arming buttons. The 3 lights in the front cockpit are labeled AMAD fire, left engine fire and right engine fire. The appropriate fire light comes on when a fire or overheat condition exists. After first lifting a spring-loaded metal guard, pressing the left or right engine fire light shuts off bleed air from, and fuel flow to, the corresponding engine, and arms the extinguisher bottle for release into the selected engine compartment. The selected bottles are then fired using the fire test switch. If the fire light is pressed again, it de-arms the extinguisher and restores normal operation of the system. Press any of the lights to continue. Fire test and extinguisher switch, off. This switch has 3 positions. Off provides normal fire warning. Test turns on 3 fire lights below and 2 afterburner burn-through lights, indicating that the fire sensors are working properly. Discharge momentarily releases the extinguisher into the selected compartments. Flick the switch to continue, but leave it at off. HUD control panel, as required. BRT knob adjusts the brightness of the HUD vector symbology. Raster video imagery is not affected. Also, applies power to the HUD when rotated clockwise. Symbol declutter. It's a 3-position switch, which removes and restores symbol information to declutter the HUD. The reject 1 and reject 2 positions are programmable by the pilot. Flick the switch to continue, but leave it at norm. The day, auto, and night switch is a 3-position toggle switch which provides the pilot with a means to select appropriate raster and vector imagery brightness levels for daytime or nighttime missions. The day position allows for the full range of the vector symbology and raster video. The auto position provides automatic brightness adjustment of vector symbology only, based on ambient brightness data. The night position limits the brightness range of the vector symbology and raster video to be compatible with night operations. The bit indicator, and the test button above it, which when pressed and held, should display on the HUD an internally generated 18 by 28 degrees field of view raster test pattern, are not yet implemented. The video brightness and contrast knobs adjust the intensity and contrast of the raster-generated video being displayed on the HUD. They also affect the navigation forward-looking infrared image brightness and contrast when the FLIR image is presented in the HUD. Master Modes. 4 CC Master Modes buttons are available at the bottom of this panel. Air-to-air, air-to-ground, navigation, and instruments mode. When any of these buttons are pressed, its light comes on to indicate that particular mode is selected. Only one CC Master Mode can be selected at a time. Click on the Air-to-Air button. On Air-to-Air mode, the CC controls the weapon system by selecting radar modes and display format for the selected weapon. It also provides computation of gunnery lead angles, missile in range conditions, missile launch parameters, allowable steering errors, and other parameters for AA weapon delivery. Click on the Air-to-Ground button. On Air-to-Ground mode, the CC generates steering commands and positions attack symbology. It also provides automatic release with weapon release switch pressed. Click on the Nav button. On Navigation mode, the CC generates navigational steering data and controls display information to the indicators. Click on the Instrumental button. The Instruments mode provides specific screens on each display unit to provide basic flight instrument displays. Computes and controls display information for instrument landings. Press spacebar to continue. Emergency Jettison button, check it's not pressed. The emergency jettison button is hot at all times, as long as the aircraft is on internal or external power. This button, when pressed, simultaneously jettisons all carded pylons, stations 2, 5, and 8, and all carded stores, CFT stations 1 through 6, and all medium-range missiles. Push the button to continue. This is safe since we don't have electric energy at the moment. Emergency brake and steer handle. Check it's in. When pulled, this handle provides additional power from the JFS hydraulic accumulator to the brake system and for the nose gear steering. In case of brakes failure, sufficient power is provided to safely stop the aircraft. Emergency brakes may feel more sensitive than normal brakes because anti-skid protection is not available. If hydraulic pressure from the utility A circuit is available, the normal brake system can be restored by resetting the emergency handle. Push the handle to continue. Rudder pedals. Adjust. On the F-15E, the rudder pedals operate conventionally and are adjustable. The rudder pedals are also used for the wheel brakes and nose gear steering. On DCS, left-click the handle and hold the mouse button down. Move the pedals to set the desired pedal distance, then release the mouse button. Circuit breakers, check all are pushed in. Circuit breakers for the Automatic Flight Control System, AFCS, pitot heat, speed brake, flaps, landing gear, and nose wheel steering, are provided on the lower center instrument panel in the front cockpit. 2 additional circuit breaker panels are in the rear cockpit, below the right and left consoles. All other circuit breakers are inaccessible to the flight crew. You can hide the flight stick by clicking its base to have a better view of the breakers. Unfortunately, the circuit breakers themselves are not simulated yet. Jet fuel starter handle, check it's pushed in. Do not pull the handle, or the JFS will start. The JFS is a small jet engine mounted on the central gearbox and along with the airframe-mounted accessory drive, AMAD, provides rotation and initial electrical power for start. The JFS itself is started by accumulated hydraulic pressure. External power is not required during engine start. Pulling the handle straight out discharges one JFS accumulator. Rotating the handle 45 degrees counterclockwise and pulling discharges both accumulators, or the remaining accumulator if one has already been discharged. The JFS low caution is displayed if either JFS accumulator pressure is low. Holding brake switch. Off. The holding brake relieves the aircrew from maintaining pressure on the brake pedals when the aircraft is stopped for long periods of time. When set to on, hydraulic system pressure, 3000 psi, is applied to the wheel brakes. The switch is electrically held in the on position and automatically switches off when a throttle is moved above idle, the aircraft is weighed off wheels, or electrical power is removed. The holding brake on signal is used by the INS to re-enter alignment after interrupted alignment occurs. The holding brake should not be placed to on while the aircraft is moving, but must be on during the AFCS bit, not simulated. Flick the switch to continue. Right console. Emergency ventilation handle, check it's pushed in and vertical. The emergency vent handle, when turned 45 degrees counterclockwise, electrically dumps cabin pressure. Extension of the handle shuts off environmental control system air to the cockpit, diverts all ECS cooling air to the avionics, and allows RAM air to enter the cockpit. If the handle is pushed in and rotated clockwise, normal ECS operation is restored. Push the handle to continue. Oxygen panel. Molecular Sieve Oxygen Generating System, MSOGS, check and set. This system provides a continuously available supply of breathing gas for the aircrew, unlike the older liquid oxygen system used on early F-15E, which had a fixed maximum capacity of liquid oxygen. MSOGS uses engine bleed air that is cooled by the ECS, and filters out the nitrogen and other pollutants, to provide oxygen-enriched breathing gas in an unlimited supply. There is a backup oxygen supply, BOS, with at least 8 minutes of supply for each crew member, to be used in case of failure of the MSOGS, or loss of either bleed air or electric power. If a total ECS failure or shutdown occurs, RAM air cools the engine bleed air from the secondary source. This secondary source provides preconditioned air to MSOGS, as long as bleed air is available from either engine. This is the oxygen supply mode control lever, with 3 positions. Off, electrical power is removed. No breathing gas is provided to the crew member. On, provides electrical power to the system, front cockpit only. Supplies breathing gas to the crew member on demand and positive pressure breathing, as a function of altitude. PBG, same as the on position, but with positive pressure breathing as a function of G load. Place the lever on, to continue. The diluter lever, controls the mixture of MSOGS gas and ambient cabin air. It has 2 positions. 100%, no dilution of MSOGS breathing gas is provided, the crew receives 100% oxygen. Normal, the MSOGS gas and the cabin air, are mixed as a function of altitude. Flick the lever to continue, leave it at normal. The emergency lever controls the crew mask supply, it has 3 positions. Normal, provides normal breathing gas flow on demand. Emergency, provides continuous positive pressure to the mask, as well as the same regulator functions operation provided in normal. Test, spring-loaded, momentary position that must be held to provide positive pressure, used to test the mask seal. Flick the lever to continue, leave at normal. The flow indicator on each regulator panel alternately shows white for flow and black for no flow with each breath under normal conditions. Continuous black indicates no air or MSOGS gas flow is being furnished, and continuous white indicates a leak in the system. The pressure gauge indicates the inlet supply pressure to the regulator. After power-up, the normal pressure is 10 to 60 psi, as indicated by the green band on the face of the gauge. The pressure will fluctuate with the breathing cycle. If the concentrator is not electrically powered, or the backup oxygen system is the source of the breathing gas, the pressure gauge indicates the gas pressure of the BOS. This pressure depends on the length of time the BOS is in use, and is a relative indication of BOS quantity. A fully charged BOS will indicate approximately 450 psi on the gauge. Breathing from the BOS is possible with pressure as low as 20 psi. Environmental Control System, ECS, panel. Anti-ice switches, set. Engine heat switch, set to off. The engine heat switch controls the engine anti-ice airflow to the engine nose cone and stationary inlet guide vanes, and electrically heats the inlet pressure probe. The Digital Electronic Engine Control, DEEC, will automatically shut off the engine's anti-ice when the altitude is above 30,000 feet, or the engine inlet temperature is above 15 degrees Celsius, or the throttle is advanced beyond approximately mid-range, regardless of switch position. The switch has 3 positions. On, activates the engine anti-ice system. Off, deactivates it. Test, checks detector operation, and turns on the inlet ice caution. Flick the switch to continue, leave it at off. Pitot heat. Off. The pitot static system employs multiple pitot and static sources for redundancy, and to provide each inlet controller with conditions peculiar to its inlet during asymmetric conditions. The pitot heat switch has two positions. On provides electrical power to the heating elements of all four pitot static probes. Off turns pitot heat off. Windshield heat. Off. The windshield anti-ice switch controls hot airflow from the primary heat exchanger to the windshield exterior anti-ice nozzle. On activates the windshield anti-ice system. Off deactivates it. Use of the windshield anti-ice system under non-icing conditions may damage the windshield. The windshield hot caution light comes on when windshield anti-ice air temperature is excessive. Engine control panel. Set. All the relevant engine-related controls are located on this panel. The F-15E simulated for DCS is powered by two Pratt & Whitney F100PW229 turbofan engines with afterburners. The -229 engine is controlled by an improved digital electronic engine control, IDEC, which automatically adjusts the engine to maintain optimum performance. Engine control switches set to on. The engine control uses a digital primary control, PRI, with a backup hydrometrical secondary control, SEC. The secondary mode can be activated either by an automatic primary mode fault action, or by the pilot manually selecting off on the respective engine control switch. During SEC mode operation, afterburner is inhibited, and engine thrust is limited to 70 to 80% of the military power available in primary mode. The pilot can attempt to restore primary mode operation by cycling the engine control switch. If the fault that caused the transfer has cleared, the engine will return to primary mode. Set these switches to on to enable the IDEC for engine control. Engine master switches. Set to on after lifting their covers. Placing either switch to on with electrical power available opens its corresponding engine fuel shutoff valve and directs power to the fuel transfer pumps. The engine master switch must be on before the corresponding engine can be coupled to the jet fuel starter. Set both switches to on and close their covers. Generator switches on. Two engine-driven AC generators are the primary source of electrical power. With both generators operating, each generator supplies power independently to certain aircraft buses. If one generator fails, it drops off the line, and at the same time, power from the remaining generator is provided to the buses of the failed, or turned off, generator. Each generator is activated automatically when its control switch is in the on position, and the generator is connected to its buses when its voltage and frequency are within prescribed limits, at approximately 56% engine RPM. Set both switches to on. Emergency generator switch. Auto. This switch controls the utility hydraulic motor-driven emergency AC/DC generator, which is separate from the primary electrical system. Its auto position provides automatic activation of the emergency generator whenever such necessity arises, and allows for automatic shutdown of the emergency generator 30 seconds after the first main generator comes online. MAN provides manual activation of the emergency generator. Isolate restricts the emergency generator to powering the emergency fuel boost pump, the arresting hook, and provides power from the emergency essential 28 volts DC bus to the emergency air refueling switch to open the slipway door. Flick the switch to continue, leave it at auto. External electrical power may be connected to the aircraft through a power receptacle near the nose gear wheel well. The aircraft buses are energized by external power in the same manner as if a main generator were operating. The exceptions to this are those buses which furnish power to systems which do not have on-off control switches and/or require cooling air. Power can be applied to these buses by the use of ground power switches. The external power switch controls application of external power to the aircraft electrical buses. In norm position, it allows them to be energized without any external power. Reset position is spring-loaded to norm, and establishes external power if it is not in line. Off disconnects external power to the aircraft. Flick the switch to continue, but leave it at off. Jet fuel starter switch. Set to on. The JFS is a small jet turbine, similar to the APU of other aircrafts. It allows F-15 pilots to start the main engines without the need to connect to external engine starting equipment. By design, the JFS can be operated on the ground, for normal engine starts, or in the air, for emergency restarts. The JFS itself is started by accumulated hydraulic pressure, and it is mounted adjacent to the CGB, central gearbox, and to the airframe-mounted accessory drive, AMAD, of each engine. The JFS powers a drive shaft to the central gearbox, which in turn transfers power by shafts to start each main engine, one at a time. When JFS is ready, the green ready light turns on. When both engines have reached idle RPM, the JFS will shut itself down automatically. Set the switch to on, to continue. Air conditioning control panel. Set. The ECS provides conditioned air and pressurization for the cockpit and avionics, windshield anti-fog and anti-ice, anti-G, canopy seal, and fuel pressurization. Air source knob, set to both. The air source knob selects the engine bleed air source for the ECS system, which it needs for its normal operation. Both takes bleed air from both engines, left or right, takes bleed air only from the selected engine. Off, shuts off bleed air from both engines. Cooling for the avionics, with the air source knob off, or the cockpit temperature switch off, automatically switches to RAM air. RAM air cooling is also automatically supplied to the avionics whenever compressor inlet duct pressure drops. Flick the switch to continue, but leave it at both. Air flow selector switch. Norm. Adjusts the cockpit air flow to maximum, normal or low flow. Flick the switch to continue, but leave it at norm. Temperature control switch. Set to auto. This knob adjusts cockpit temperature. Its positions are auto. The cockpit temperature is automatically maintained at the temperature selected with the knob underneath. Manual, the cockpit temperature can be adjusted with the knob, but it is not automatically maintained. Off, turns off the ECS air to the cockpit, avionics, and windshield anti-fog. The avionics cooling automatically switches to RAM air. The canopy seal, anti-G, and windshield anti-ice continue to operate. Flick the switch to continue, but leave it at auto. Cockpit temperature control knob, as desired. Interior lights controls. As desired. Except for the utility floodlights and UFC display lighting, all the controls for interior lighting are on the interior lights control panel on the right console in each cockpit. Console. Adjusts the console lights, which provide variable lighting between off and full bright. Instrument panel knob, adjusts the instruments panel lighting. Integral lighting is provided for all instruments and panels on the front cockpit instrument panel, including the MPDs, MPCD, UFC, circuit breaker panels and the HUD. Lighting is also provided to the radio call, emergency hook and emergency vent panels. Instrument lighting is provided to the front cockpit standby compass whenever the standby compass switch is on. Lights test switch is provided to test the warning, caution, and advisory lights, and it's spring-loaded to its off position. When set to on, all of these warning lights will come on, except takeoff trim. If in the low-intensity night mode, the lights will test at the dimmed setting, as controlled by the warning caution control knob. UFC. This brightness knob provides a full range of adjustment for night utilization. Backlighting is not required because the LCD is a reflective type display. Standby compass. Lighting for the front cockpit standby compass is controlled by this switch and the instrument panel knob. With the switch on, variable lighting is provided between positions off and bright of the instruments panel knob. Flick the switch to continue. Chart light knob. A chart light is provided in the front cockpit on the canopy bow and in the rear cockpit above the right console. The lights, which illuminate maps and other documents on the crewmember's knee board, are mounted on adjustable positioning joints. Display. Controls the maximum illumination level for the MPD and MPCD displays. The positions are day and night. Flick the switch to continue. Warning, caution. Independently switch the warning, caution, and advisory lights from bright intensity, day mode, to the low intensity range, night mode, and then to vary the brightness within the low intensity night mode. Storm flood. The front cockpit has a floodlight above each console and two above the main instrument panel. The rear cockpit has one floodlight above each console. Adjust their brightness with this knob. Utility floodlights. On the real aircraft, a portable utility floodlight is provided in each cockpit, and is normally stowed on a bracket above the right console. This utility light is the only cockpit light which can operate from JFS generator power. On DCS, this light is simulated with the DCS flashlight, that you can toggle with the left Alt+L keys. Good, you have now finished our left to right sweep of the front cockpit. Now we will move on to the rear seat, to do a similar sweep of the rear cockpit, following the rear cockpit interior check procedure. Press the 2 key to occupy the seat of the Weapons Systems Officer, WISO. Okay, we are now seated on the WISO position, and on the same way as we did with the pilot's cockpit, let's begin reviewing the different elements on a left to right sweep, following the official rear cockpit interior check procedure. Press spacebar to begin. Rear cockpit, left console. Intercommunications control panel, set. Volume knobs, as desired. These knobs are identical to those we already explained on the front cockpit. Tactical electronic warfare system volume knobs. The top knob is used to set the volume of caution sounds, the bottom one controls the launch warning volume. Intercom and weapons knobs. The top one adjusts the audio volume of the intercom system, and the bottom one the weapons lock-on tone. The rightmost knobs set the volume of the ILS audio and TAC and beacon sounds. Press spacebar to continue. IFF Mode 4 Crypto Switch. Norm. The crypto switch in the rear cockpit is spring-loaded to norm. Its positions are: hold, stores the Mode 4 crypto codes in the IFF memory, preventing automatic zeroing of the codes at power shutdown. Norm, normal operation, where the codes are erased at shutdown. 0, sets the code settings back to 0. Seat ejection also zeroes the codes automatically. Flick the switch to continue. Mic switch, on. Operates identically to the same switch of the front cockpit. Selecting on provides direct communication from the cockpit in which it is selected with the other cockpit or the ground crew. Set mic to on to continue. Voice warning silence push button. Pressing this button silences the voice warnings and the oral tones in progress for 1 minute. If still present after 1 minute, the warnings will be heard again. Cipher text switch, as required. This switch is identical to the one on the front cockpit. Unfortunately, on DCS ciphered communications are not simulated. The tone selector switch allows the crew to transmit tones on the UHF-1 or UHF-2 radio by selecting either position. Electronic Warfare Control Panel. Set as required. Currently, this panel functions are not being simulated for DCS, however we will briefly describe how they work on the real aircraft. RWR, ICS mode switch. Selects between training and combat modes. Flick the switch to continue. This switch activates the ALQ-131, an electronics countermeasures pod that the F-15E can carry. Not currently simulated. The rear cockpit intercom system switch has 3 positions, MAN, auto, and off, but its effect is not currently being simulated. Sensor control panel. Set. The sensor control panel of the rear cockpit is used for targeting pod operation. TGT FLIR power switch. Off. This switch has 3 positions: off, standby, which initiates the sensor's cool-down process, and on. The level and gain knobs are used to manually adjust the sensor's image quality on the MPD or MPCD, and fine-tune it to the pilot's liking, in case the automatic level gain is not satisfactory. Laser switch, safe. The laser arm switch has 2 positions, safe and arm. If the switch is in safe mode, it is impossible to use the targeting laser, but the laser marker functions will still work normally. Flick the switch to continue. Nuclear consent switch. Safe, cover fully closed. This guarded switch is exactly the same as in front cockpit. It allows the crew to release or jettison nuclear weapons on board. Both front and rear cockpit switches need to be enabled for release or jettison. Canopy jettison handle, forward. It works exactly as the one on the front cockpit. Pulling the handle aft fires the canopy jettison system. Please, do not try to operate this handle, as it works even with no electric power. Press spacebar to continue. You have jettisoned the canopy. The crew chief is going to be furious. You may continue the training, but be prepared for some major explaining to the commanding officer. Emergency landing gear handle. Check it's pushed in. This handle works in exactly the same way as the one on the front cockpit. On DCS, a right click will turn the handle, while a left click will push or pull it. The handle can be pushed forward only when it's rotated from the vertical. Pull-push on the handle to continue, leaving in vertical position. A resting hook switch. Check it's up. Again, the hook switch works exactly the same as the one at the front. Flick the switch to continue. Emergency brake steer handle, check it's pushed in. This handle works on the same way as we already saw with the front cockpit. Pull-push the handle to continue. Rudder pedals. Adjust. Same as with the front cockpit, the rudder pedals operate conventionally and are adjustable. On DCS, left-click the handle, and hold the mouse button down. Move the pedals to set the desired pedal distance, then release the mouse button. Press spacebar to continue. Command selector valve. Check it's at norm, vertical. The command selector valve is provided in the rear cockpit to select the desired ejection sequence when it's initiated from the rear cockpit, or to provide for single ejection for solo flight. Its positions are norm, single rear seat ejection when initiated from the rear cockpit. Dual ejection, rear seat first, when initiated from the front cockpit. Aft initiation, dual ejection, rear seat first, when initiated from either seat. And solo, ejection from the front seat is immediate. The aft seat will also eject after the forward crew member has ejected, even if this mode is meant for solo flight. On DCS, a left click turns the handle counterclockwise, a right click turns it clockwise. Twist the handle to continue, but leave it at norm. MSOGS, Molecular Sieve Oxygen Generating System, check and set. This panel works exactly the same as the front cockpit's oxygen panel, except that only the front one is able to provide electrical power to the system. This is the supply mode control lever, with 3 positions. Off, no breathing gas is provided to the crew member. On, supplies breathing gas to the crew member on demand, and positive pressure breathing as a function of altitude. PBG, same as on, but with positive pressure breathing as function of G load. Place the lever on, to continue. The diluter lever controls the mixture of MSOGS gas and ambient cabin air. It has 2 positions. 100%, the crew receives 100% oxygen. Normal, the MSOGS gas and the cabin air are mixed as a function of altitude. Flick the lever to continue, leave it at normal. The emergency lever controls the WISO mask supply, it has 3 positions. Normal, provides normal breathing gas flow on demand. Emergency, provides continuous positive pressure to the mask as well as the same regulator functions operation provided in normal. Test, spring-loaded, momentary position that must be held to provide positive pressure, used to test the mask seal. Flick the lever to continue, leave at normal. The flow indicator alternately shows white for flow and black for no flow with each breath under normal conditions. Continuous black indicates no air or MSOGS gas flow is being furnished, and continuous white indicates a leak in the system. Press spacebar to continue. The pressure gauge indicates the inlet supply pressure to the regulator. Tactical Electronic Warning System, TEWS, Control Panel. Set. The TEWS is an integrated defensive suite, consisting of 4 separate subsystems: Radar Warning Receiver, RWR, which displays threat identification and location information to the aircrew, on any selected MPD or MPCD. Internal Countermeasure Set, ICS, which is a software-controlled self-protection radar jammer. Electronic Warfare Warning Set, EWWS, which uses an array of antennas to detect and display various threats and other information, based on their radar emissions. Countermeasures dispenser, CMD, is a computer-driven, internally mounted, chaff and flare dispenser. ICS switch, off. This switch powers the ICS jammer. The jammer is not fully functional in early access version of the simulator. Flick the switch to continue. These are the set 1, 2, and 3 switches and status windows, which control different modes of the jammer. They are not currently simulated. RWR switch, check it's off. This switch powers the radar warning receiver. The RWR is largely work in progress, and many things may still be changed or added at a later stage. EWWS switch, off. This switch powers the electronic warfare warning set system. Its tone defeat switch is not simulated yet. Press spacebar to continue. Countermeasures dispenser control panel, set. This panel applies electric power to the CMD, allows selection of payload dispensing modes, and selection of flare jettison. Dispense select switch. Whenever the mode knob is in a position other than off, the three positions of this switch, chaff, both, flares, provides different dispensing for the M01 and M02 programs. Flick the switch to continue, but leave it at both. Mode knob, off. The countermeasures mode knob has the following positions. Off, the dispenser is not operational. Standby mode, enables warm-up of the system and full bit, with weight on wheels. M01 only, the system accepts dispense inputs via programs M01 and M02. Semi-auto, the dispenser relies on the data provided by the RWR to prepare the best dispensing program against specific threat. The pilot can still use M01 or M02 to use different programs, and has to manually initiate dispensing countermeasures. Auto, it's like semi-auto, except the CMD automatically initiates dispensing countermeasures. Flare jettison switch, norm, cover down. The flare jettison switch is a guarded, two-position switch with the following functions. Norm, the countermeasures dispenser operates normally, as per the current position of the mode switch. Jet, overrides the position of the mode select switch, even if it is in off, and dispenses all the onboard flares ignited. You would use this switch prior to attempting a forced landing, to avoid the fire risk that the flares represent. Circuit breakers, all in. The circuit breakers panels, located on both cockpit side walls, are currently not simulated for DCS. Interior lights controls, set as desired. This panel is almost identical to the one we already saw on the front cockpit. Console. Adjusts the console lights of the rear cockpit, providing variable lighting between off and full bright. Inst panel, adjusts the rear cockpit instruments panel lighting. Rear cockpit integral instrument lighting is provided for all instruments and panels on the rear instrument panel, including the MPDs and MPCDs. Integral lighting is also provided to the UFC, the command selector valve panel, the emergency hook panel and the radio call panel. Press space. LT test switch is provided to test the warning, caution, and advisory lights, and it's spring-loaded to its off position. UFC. This brightness knob provides a full range of adjustment for night utilization. Backlighting is not required because the LCD is a reflective type display. Standby compass. In the rear cockpit, although a switch is provided, there is no standby compass installed. Chart LT. A chart light is provided in the rear cockpit above the right console. Display. Controls the maximum illumination level for the MPD and MPCD displays. The positions are day and night. Flick the switch to continue. Warning and caution. Independently switch the warning, caution, and advisory lights from bright intensity, day mode, to the low intensity range, night mode, and then to vary the brightness within the low intensity night mode. Storm flood. The rear cockpit has one flood light above each console. Adjust their brightness with this knob. Press spacebar to continue. Very good. You have completed this front and rear cockpit familiarization training mission. What you have learned will help you to better understand the next training mission, cold start the F-15E Strike Eagle. Press spacebar to exit from the mission.